Hello! In this video, we present the retrosynthesis of phenobarbital, isotopically labeled with carbon-14 or nitrogen-15, useful in the research of the pharmacology of this antiepileptic drug. Phenobarbital labeled with nitrogen-15 presents an endocyclic urea substructure, which can be considered as a retron. With this idea, a carbon-nitrogen disconnection, based on a retroamidation, it opens the cycle and gives rise to the first precursor, where X can be an ethoxy group, chlorine, or another leaving group. A second carbon-nitrogen disconnection generates the malonic acid derivative 3, whose retrosynthesis was already presented in a previous video, and the urea labeled with nitrogen-15. A carbon-nitrogen disconnection in the labeled urea generates the labeled carbamic acid 5 and the labeled ammonia-6 as raw materials. A carbon-nitrogen disconnection in the carbamic acid generates carbon dioxide and the labeled ammonia-6, both as raw materials. Next, the retrosynthesis of phenobarbital labeled with carbon-14 is presented. In the same way as in the previous case, the endocyclic substructure of urea is considered as a retron, and a carbon-nitrogen disconnection generates the urea derivative 9. A carbon-nitrogen disconnection in 9 generates the malonic acid derivative 3 and the labeled urea 10. A carbon-nitrogen disconnection in 10 generates the labeled carbamic acid and ammonia as raw material. A carbon-nitrogen disconnection in the carbamic acid generates the labeled carbonic acid and again ammonia as a raw material. The labeled carbonic acid is considered as a synthon whose synthetic equivalent can be the labeled carbonate with carbon-14, where M represents the ions of the metals barium or calcium. In summary, here the disconnections for both cases are shown. In the next video, the resulting syntheses will be presented.